appropriate personality for this function and this conference, because he is into this innovation right for the past 20-25 years. And you remember my college days, even Prakash, he was our project group leader and he used to take initiative. He always took pride in working on innovative ideas, and he has persisted and he has continued that research acumen and research attitude. And we are really blessed in a sense. He already has 14 registered patents against his name. And those patents are in various fields of technological innovation. It's a really matter of pride that such a personality is with us. His words of wisdom will definitely guide all of us for innovative research. I welcome him from the bottom of my heart, or from the abyss of my heart. I welcome him and thank him for giving his valuable time for this function. Thank you, sir. So once again, I welcome you all and hope we'll have very nice deliberations throughout the conference. Thank you. Jai Hind. Now, I request our keynote speaker, Engineer Prakash Kulkarni sir, to formally declare this NITET 2020 open for all. Prakash sir, please.
Thank you.
You can just formally declare.
Yeah, so I formally announce or declare that this conference on the innovation trends and innovation and technology trends is open for deliberations today. Thank you very much.
Just now we have watched the video of NITET. So now I request our principal, Dr. S.A. Patil sir, to speak a few words on this event.
Good afternoon to all. Am I audible?
Good afternoon.
Yes, sir. Yes, sir.
Okay. So the various dignitaries present for this conference. Okay, I am very happy to welcome all of you. Regarding our institute, I would like to just explain in few sentences to the various researchers and the guests also. Our institute was established in 2008, AGPIT Institute of Technology. Along with this, AGPIT Polytechnic Institute was also established in 2008 in the same campus. In Shanti Education Society was established again in 2008 by our Honorable Chairman, Sri A.G. Patil sir. And this Shanti Education Society's Secretary sir, Sri S.A. Patil sir, he is looking after the entire day-to-day working of the Pal Institute. This A.G. Patil Institute of Technology, presently we have got 4 branches: mechanical, civil engineering, electronics and telecommunication engineering, and computer engineering. Along with this, we have got one PG branch, that is M.Tech in mechanical engineering. Our institute is affiliated to Dr. Babasaheb Ambedkar Technological University, Lonere, since 2017-18. Now we are in the 4th year of this DBATO affiliation. Our institute is NAAC accredited, and our sister concern, A.G. Patil Polytechnic Institute, is MBA accredited, and shortly also we will be going for this MBA accreditation. So in this year 2020, our 9th batch passed out. and almost more than 1,500 engineers are working in various categories, in various positions, in various. I am very happy to welcome all of you for this deliberations which is going today. So I heard that there are many papers have been received from all over the India, and those deliberations will be shortly going on after this inauguration function. So I expect that these deliberations will be very helpful to all researchers as well as to all our students as well as the faculty. And I really congratulate all the organizing committee members for organizing this NITET, that is National Conference on Innovative Trends in Engineering and Technology, since last about 4 years. So I wish all the best for all these researchers, and thank you very much.
Thank you, sir. Now I request HOD of Mechanical Department, Dr. Gadwal sir, to give introduction of keynote speaker.
Good afternoon, sir. Good afternoon, all respected dignitaries. It is my privilege and honor to introduce the keynote speaker, Professor Prakash Kulkarni. I have used the word Professor. This will be disclosed at the end of the that is introduction. So basically, he is a co-founder and director of Metec Solution Private Limited. Did his graduation from Karnataka University in the year 1984. Did his PG diploma in business management from Pune University and MDP Business Administration and Management from Ahmedabad, IMI. Professional background and key positions which he has held for the last 34 years, having an industrial experience in different organizations and in multiple roles like vice president, director and innovation. He was a chief engineer for 10 years in automation and robotics design at Philips Singapore. Electronic systems, robotics, manufacturing are the working field. 2001 to 2020, he being the director of engineering and innovation at Adient India and Metec Solution. He is the co-founder and director since a new startup has been started, that is in 2020, having a medical equipments and design and manufacturing. And in his name, a patents of 14 has been registered in multiple fields of engineering. Now I have used the word professor. So he is a visiting faculty for MTech students at ARAI on automotive safety design, passive and active. Sir, I welcome to this NITET 2020 and I hand over the mic to you so that you can continue. Thank you, sir.
Thank you, Professor Gadwal, and thank you, Dr. Vishwajit Poddar, sir, and Principal Dr. Sunil Patil, sir, and all the dignitaries and all the faculty members on the conference today. It's my privilege to be part of this conference, and I really thank Vishwajit for arranging this. We have been talking about this for quite some time, but it was somehow not materializing because of my commitments earlier in the organizations. So good that I am able to contribute something to this conference today. One point I just wanted to highlight that I have been mostly in the industrial environment. After my passing out, worked with the industry, different industries at different organizations in different roles. But basically, I'm a mechanical engineer, and always, as all the mechanical engineers do, you try to find solutions to any problems. Now, it has been sort of imbibed in my way of working and in my, handling the situation. So you face a lot of problems, and always you are trying to find the best solution which can be a sustainable and a long-lasting solution. So that is basic, part of the human aspect, which really helps to innovate. And many times you find that you do a lot of things, but you get into a lot of failures also. But I think only way to continue and to make effort to get the right solution. So once again, thank you everybody for this opportunity. And probably I would like to go to the screen. I would like to share my screen, and I have compiled some information which is partly coming from my past experience, from my earlier methodologies. Again, this is more towards the industrial applications. So sorry if I am talking too much about the manufacturing segment or industrial environment, or talking too much of business and those aspects. But as Vishwajit said, that it is also important for academic institutions like the AGPIT Institute, where you are doing a lot of good work and trying to do some innovative things for the social cause. That is very good, because I think that is where we have many problems in our society, which are not being addressed, or which are having little attention. And it is good that your institute is taking that initiative to help the society in which you are sustaining. So with that small introduction, maybe I'll try to open my presentation. So today what I'm trying to give here is a overview on innovation, and the process which we used to follow in our organization, and also the latest trends. We have actually 20 minutes, so I'll try to cover up this in 20 minutes. So always there has been a question like, what is innovation? So I just collected a few definitions of innovation. So innovation is the process of translating an idea or an invention into a product or a service which creates value and also serves to meet unmet needs of the user, and also the customer is ready to pay for it. So what we are trying to say here is innovation is something which converts an idea into a product or a service which the customer is ready to buy. That means the idea is not in the books or in the laptop, but it is really converted into a usable product and a concept which can be then used by the end users, and they appreciate the value of that idea. It can be through better services, or it can be a new product or an improved process, and strengthened by differentiating with the current competitive products, defensible, and which is also sustainable. In our industrial language, we call this innovation as a sweet spot between three different aspects of in any industrial business understanding. So is the idea technically feasible? We look at the feasibility of the idea, whether technically it is possible to build it, to make it. From the user side, we always look at the desirability of the user to use it, or whether he is going to buy it, and whether that is going to really provide that additional value which that idea is supposed to deliver. And for the organizations, we always look at the business viability, whether this innovation whether makes any business sense, whether the organization can afford to invest something upfront and then get some benefits out of that. It could be a social benefit, it could be a financial benefit, or it could be any other benefits, tangible or intangible. So this is what we call as a innovation, which is sitting in the sweet spot between these three aspects of any organization. Now let us look at some of the definitions and differentiation, because there are many words like innovation, invention, and continuous improvement. So I'm just trying to put some clarity on these three concepts here. When we say innovation, as we saw, it's a better idea or a more effective device or an improved process. And this is viewed as application of better solutions, which can meet new requirements. And this is accomplished through more effective products, processes, services, or technologies, and the ideas that are readily made available to users, markets, governments, and society. Now, again, the word invention. So I just want to put a small clarification or understanding here. Invention refers to more directly creation of an idea. So, for example, light bulb was invented by Thomas Edison, or X-ray was invented by someone. So those are the inventions which are creation of a new idea. Whereas innovation refers to the betterment of that idea, or making that a product more effective and improve a process. So that's slight differentiation is there. And when we talk about continuous improvement is something, you can do certain things in a better way. They always try to find a better way of doing certain things. So this is basically a little bit of clarity on innovation, invention, and continuous improvement. Next slide, please. So another question which always being asked is, why innovation is important. Now, when we look at the aspects, next slide, please. You always look for uh, a continuous improvement or a breakthrough improvement in your business, in your profitability, in your revenues. Next slide, please. Yeah. So why innovation is important? Because innovation is essentially important to be successful in the marketplace with better products and services, and also to improve the business growth expectations. So innovations can help you to add revenues, improve the profitability, improve your market share, and improve the brand image of the organization. It's a strategic priority for organizations to sustain in the competitive market. So with your improved and innovative products, you can always have an edge over the competition, and you can command more sales and revenues. Many times only operational excellence and continuous improvements, they alone are not enough to be ahead of competition, and that is where innovative companies, we'll see that in the next few slides. Some of the innovative companies, how they are able to grow, how they are able to make a big revenue and growth through innovative products. Next slide, please. Now, next question comes is there a process for innovation, or is it like an ad hoc way of innovating? So there were certain times in the earlier days where a smart and brilliant chap can come up with some idea, and then he could try to do something to get that idea popular, get that idea manufactured, or sell that idea. But because of the lack of some basic processes, you always tend to fail, or you always tend to not being successful in the society. So there are processes, and to innovate, you need to have a predictable and a systematic way approach, so that what comes out of the process is more reliable, more sturdy, and more sustainable. So we call it, why, how, and what. So why you have to innovate, how you have to innovate, and what you should innovate. So these are the basic three questions which we ask before we start any innovative development process. Next slide, please. Now, what I have tried to do here is, this is actually a single page summary here, but each of these four stages, we have a very detailed and very systematic, I would say, activity chart, activity list, and some measurables, so that you can take the raw idea into a commercialization. So basically, this calls is a milestone-based process, and it has mainly four stages. The first stage is opportunity stage, and then we call it a pursuit stage. Then it goes into a realization, and then in the commercialization phase. So on the left hand side, you see a lot of ideas. Where before you start the journey, you will say that I have to do some brainstorming, and after the brainstorming, then you have a problem for which you try to brainstorm and try to find multiple solutions. Now that is where we call it as an opportunity stage, where you define the problem and then do some research, do some workshops, bring people together, do some brainstorming, and try to find out uh, what are the possible solutions for that problem. Now you might come up with, say, 200, 300 ideas for a problem, and then once you do a detailed deep dive of those all the ideas, you will find that some of the ideas are either not relevant, or some of the ideas have been duplicated, and some of the ideas are probably already in the market. So you remove all those duplicate and already available ideas, and then you shortlist maybe from 200 to 10. You say, okay, these are the 10 potential ideas which are worth taking to the next step. So the next step is pursuit phase. Pursuit phase is where you look at these 10 ideas, and then you start making some initial models, studies, make some concepts, make some samples, and then try to pressure test them, try to do some initial very high level test requirements. You subject them to some impact, you subject them to low deflection criteria, you probably take them to a bunch of selected people, where you say, okay, this is the idea, tell me whether it makes sense for you, or whether you are happy with that. And once you complete the study for all these 10 ideas, again you come together, and then you see, okay, out of those 10 ideas, you probably find only 3 or 4 which are really make sense, which are really uh, good to taken to the next stage. Uh, that comes to the realization phase. Realization phase is something where you really focus on these 3 ideas which have come out of the pursuit phase, and you are sure that these 3 ideas are the most feasible technically, and again the users are quite happy with that. They really see value in those 3 ideas, and also from the business point of view, probably it makes sense, and there is worth potential to take these ideas into the commercial phase. Now, when you look at these 3 ideas and then you see the commercialization phase is nothing but you really now look at the building the business. You really look at probably having a plant, having the resources to start manufacturing the concept and the product whatever you are working on, and then you try to scale it up. You want to make hundreds of those products repeatably and sustainably, so that you are able to mass manufacture and then sell it in the marketplace. Now here again, once you start mass manufacturing, you might find that some of the ideas are better, or they are easy to commercialize than the others, and probably you focus on the one which is most suitable, most valuable, and most technically feasible for mass manufacturing. So again, as I said earlier, this is a typical process which is followed in the industry, or rather I would say in my industry where I've been working. But again, if you apply this to the educational institutes, probably there is some different process which is required, but the aspects, more or less the aspects would more or less remain same unless it's a one-time activity or you want to do as a mass, mass addressing innovation. So some differences between industrial and academic processes, but I think that is where this industry academia collaboration is very, very important, and that is where you see the industrial part of it, how the industry does it in the field, whereas for the industrial teams it is good to know how we do that in the institutes and academic uh, establishments. Next slide, please. Now, here I have just put some companies' names. I think probably everyone of you will really recognize and agree with me that these are the few companies which have been successfully doing innovations, successfully, making products which are different, which are unique, which are providing best value to the end users, and they have their own specialities, they have their own uniqueness, they have their own way of resolving some or the other problems for the end user. So I will not go through each of them, but I have only picked up one or two cases. So Apple, famous for all the iPhone and iPod and all the gadgets. Tesla is really growing very fast with the electric vehicle products. Google has come up with so many new innovative ways of communicating and connecting the communities. Amazon has their own way of bringing the products or making end user a very satisfied customer by providing him a user friendly process or access to the markets and delivering those products to their home as such. Samsung is also doing a lot of new innovative things from the mobile phones and TVs and other products. Flipkart is again a example for India where it started with uh, uh, online shopping experience. We know Facebook, Ola, again an Indian company which really transformed the uh, transportation or service transportation services to the users from point A to point B, and making the cabs available whenever you need it. Oyo is another example of providing a very good residential facilities or hotel room facilities whenever you travel last minute. So these companies have been doing innovation in a way or the other to be establishing in the marketplace and also making huge revenues and providing values in their own specific services or products which they are offering. Next slide, please. So I have picked up Apple as one of the global innovative company, a technology-driven company which has been bringing products which are different, which are way above the standards which are available in the market. So we also look at the vision and mission statements of these companies. How the innovation culture is directly imbibed into their vision and mission statement. Because when you say that we believe that we are on the face of the earth to make great products, and that's not changing. So they are very confident that they can make great products, and that is their vision. And when you look at the mission, they say to bring the best user experience to its customers through its innovative hardware, software, and services. So Apple is a company which really came up with innovative hardwares like the iPhones and iMacs and iPods, and also coupled with the softwares like Macintosh was their initial, and now they are having the iOS for all the handheld gadgets and wearables, and also they are into services like the TV services and other music and offering musics on the online. I think the history is known. Steve Jobs and Steve Wozniak, they co-founded in '77, and they introduced to Apple One and Apple Two initially. But they were almost bankrupt during '90s because the Macintosh was not really selling, and they had a lot of setback. And then they again came back very strongly after 1997. Came up with the iPod, the first product which really hit the market, and it was very popular. And then they started making the iMac, iPhones, iPads, and I think the rest is the history. So Apple is a example at a global level how an innovative company can really make the difference in the life of people, and how the products can offer tremendous value to the users. And if you just look at the net worth, they are almost $2 trillion as of August 2020, which is I think higher than or in between the country's GDP of the Belgium and Luxembourg. So they are equal to country's GDP, which is huge, huge growth. Next example, please. Yeah, and this I have picked up Flipkart as an Indian company. Again, online marketplace in India. Again, if you see the vision mission to become Amazon of India. So Flipkart, when they started, Sachin and Billy Bansal, they both were working with Amazon. They decided to come out, and then they decided to do something similar for the Indian market. And they started selling selling books in 2007, and in between they added a lot of products and a lot of services, and now they almost sell everything from personal care to jewelry to CDs and stationery and computers and mobiles and whatnot. They also acquired Mantra in that was in 2016, I think, and now they are one of the top 5 global billion dollar startup club. They have entered into that club with a valuation of $11 billion. And recently, Walmart acquired 77% stake in Flipkart for $16 billion. So Walmart is again a heavy competitor of Amazon. So they wanted to be present in India to take head on with Amazon and also get some market share in India. So these are the two big companies which have proven that the way one is bringing innovative products to the marketplace, the other one is bringing a innovative process or a customer experience, a memorable and delightful customer experience to buy online. So it's a online marketplace and enhance your shopping experience. So these are the two examples which again give us an idea about how innovation can make the difference in the growth and in the branding of the organizations. Next slide, please. So with that basic overview and some of the examples, now we go to the future trends. I think the conference is basically, the topic is what are the new technologies and new innovative trends for the future. Again, next slide, please. So what I did was I tried to get into the Forbes open database. These are the top 6 or 7 technologies or innovations which are probably going to come in the near future. Maybe some of them are already there, and for India probably they are also lined up, and we will be seeing these coming in India also in sooner or later. So artificial intelligence, 5G networks, autonomous driving, personalized and predictive medicine, computer vision, extended reality, and blockchain technologies. So these are the seven which I have picked, but there are many others to name a few, like Internet of Things, or home control modules. I think in the institute and the educational phase, there are online training modules. There are many new uh, ways of expanding, new ways of providing the online education to the children into the rural parts of India. I think a lot of apps are already being um, done. Byju's is one of them, and I also saw one more yesterday, which is Vedantu or something. So people are coming up with a lot of new ideas to provide education and provide learning to the students, to the people. So I will just go through each very briefly. I think I am already, yeah, maybe another 5-10 minutes. I'll stop at 3:30. Next slide, please. So we know artificial intelligence is becoming a buzzword, and most of the companies are using it now. The next step would be that offering artificial intelligence as a service. So today we see software as a service also coming up as a new business. But in future, we will also see artificial intelligence as a service. Now, this is basically most companies have started to explore how they can use artificial intelligence to improve the customer experience, and people are trying to come up with design and deploying of our own AI-based systems, but they find that developing something on your own is going to really become very expensive and may not be able to many businesses may not be able to afford it. So there is a possibility that somebody who has a lot of knowledge, a lot of data which is collected on artificial intelligence, he can offer those services, and the small businesses can use that data as a input for their process. So many platforms are likely to come in future, and we are going to see wider adaptation and a growing pool of these data providers for the AI. So AI is going to become a key parameter or a key, I would say, attribute of any businesses going forward to enhance the customer experience. Next slide, please. Yeah, 5G networks. This is next level of, I would say, internet connectivity. Today we are operating at the 4G, and there are already a lot of work going on 5G. And yesterday, when I was looking at the Apple's launch event, it was first time the launch event was online. Normally, it used to happen always in person. But yesterday, Apple has introduced or launched a 5G mobile phone, iPhone 12, for the first time, and they're already looking at having the 5G network connectivity in USA. And one company called Verizon, they're already helping them to set up the 5G network in US. So we are going to see this 5G network slowly spreading into other countries. Already in China, Huawei is very aggressive on 5G, but there have been some disputes and some issues because of the tensions. But I think 5G is really going to become important. India has already signed an agreement with Japan and Korea to collaborate and come up with 5G network possibilities in the Southeast Asia regions, and they are working on it. So what is important for uh, adopting to 5G is super fast download and upload speeds, and this is really going to change the way we communicate, the way we you know talk to each other and share the data. So this is really going to have a huge impact, and not only the end users who are really going to see a tremendous increase in the speeds of communication, but it's also going to have some impact on the industry. We'll have a lot of efficiencies coming out of the manufacturing processes because of the super fast and stable internet access. We are going to see a lot of improvements in the functioning of robots, and also the 5G network is really going to help the autonomous vehicles to function even better. So 5G is really coming, and probably you will see that in our day-to-day lives in a few years in India as well. And it will also complement the initiatives of Internet of Things and smart machinery, which will enhance the way we do the things on internet. Next slide, please. Autonomous driving, I think those who are really connected to the automotive field, probably might have heard about autonomous vehicles. A lot of efforts have been put in by different big um, automotive companies like uh, Tesla and Ford and GM and others, and everybody is trying to bring the vehicle with highest level of autonomy. So there are some steps. I mean, how much autonomous you can do. I think there are 5 steps, and today we are already seeing autonomous vehicles at this stage 3, and they are slowly trying to bring stage 4. But stage 4 and stage 5 will become very, very difficult, because there you really have literally no human interference in the functioning of the vehicle. So that is where they are struggling to really bring it to the stage 4 and stage 5. So to come to that autonomous vehicle, probably it's long wait for India to see that, but the developed countries like US and Europe, they're already working on it, and they have a lot of difficulties. They have faced a lot of issues in terms of safety and in terms of the way these vehicles are uh, able to move around themselves, and a lot of work is going on right now to make it as safe as possible. So Tesla, other than Tesla, Google has entered into this. They have a sister company called Waymo, and they are doing some taxi trials of autonomous taxis. And also the heavy commercial vehicles like trucks and shipping are also now entering into this, trying to bring the autonomy of driving there. And probably you will see a lot of things coming out of this in 2020 or 2021. Along with autonomy and self-driving ability of the vehicles, there are a lot of issues. So the regulators, the government bodies, legislators, they're also working on bringing new laws, bringing new regulations, so that the autonomous vehicles are safe, and they also are supported by the infrastructure which is required for the autonomous vehicles, and so that it can really become a practical mode of transport in the future. But a lot of work still has to go in this, but this is something which most of the companies are working on. Next slide, please. So another development which is happening around is the personalized and predictive medicine. Now, if you see the current way of offering treatments to the end users or the patients, is physically a person has to visit the doctor, and then you give your problems, and then the doctor, with because of his experience and because of his way of handling the things, he might suggest you certain medicine, and he'll ask you to do some tests, and then you get your treatment. But slowly, first of all, this is going to become online, and we already see that happening during the COVID situation. Many of the hospitals and many of the doctors have started doing teleconsultation. You can just call in and you say this is what is happening, and then probably they will ask you for certain symptoms, and then they will provide you some medicine. So it is already happening here. But the next step of that would be really to predict the health issues. So a lot of data has been collected through the smart watches and through the other appliances. So your BP is known, your pulse rate is known, your oxygen levels are known through your smartwatch. So this data can be seen, or they can be collected, and uh, with the help of AI, the doctors will be really able to predict if you are going to get into some trouble in coming days, and probably that is what is probably next step. And also they will be able to really provide you the treatment in a very personalized way. Like everybody has a different bio parameters. Everybody is different, and one tablet for all may not be the way it will go in future. Probably we will have something different, a unique combination of some medicines to address your problems. So it is all going to be data driven. It is all going to be predictive. You will be able to get some advanced information. You'll be able to get some um, personalized way of having the medication, and uh, this is really uh, supported by the tele consultation mode and video, and you can really get the treatment being at any part of the world. So that is predictive and personalized medicine. Next slide, please. Computer vision. Yeah, I think computer vision is already we see a lot of the vision elements in our smart cameras, and there are many sensors which are being developed to identify atoms, to identify a place or object, or even your face can be captured with the cameras and all. So we are already getting used to this way of approach, but probably the next way would be that this will be also coming into the tools and the manufacturing and technology segments. Again, one of the fundamental requirements for the autonomous car is a sensor which can see the obstacles, which can really sense whether there are any people or any movement happening in front of the car, and then they can either navigate around that, or they can really stop, or they can reduce the speed, or they can avoid that object. So a lot of things are happening on the vision based systems. These systems, they really capture a data, and then they give feedback to the microprocessor to take a next action. So again, this is coupled with AI. They are making a system which could replicate a sort of human reaction to any risk or any danger. Um, face recognition, already we are using it, and there is an expansion of that um, feature for controlling access. Even in the airports, in Dubai airport, I think they are using the Face ID to have a smooth immigration clearances and other things. So computer vision is really going to expand into multiple applications in coming future. Next slide, please. Extended reality. Yeah, I think this is a term which probably is most heard of right now. and it also includes three different types of extended reality: virtual reality, augmented reality, and mixed reality. So what this does is, for example, virtual reality provides a fully digitally immersive experience. So you have a computer generated world around you. You put a headset, and then you are part of the digital world. Now, I have seen this happening in automotive industry. When a car is being designed, or interior of a car is being designed on the CAD or on the software, probably you don't have a sample, you don't have a physical interior vehicle to review. So I have been part of some reviews where the CAD system, the design is uh, done or reviewed virtually. So you really put a headset, and then you walk into the car as if you're sitting inside the car. You go inside, you can see the steering wheel in front of you, you can see the dashboard in front of you, you can see how the glass, the windshield comes up, whether you have the proper visibility, or whether your head is touching the roof, or you can do a lot of reviews using the digital immersive review, like virtual reality. And this is happening, I already see that in the industrial applications. Augmented reality is something where you have a real world outside, but then you put a digital product into that, and then you see whether this really is good enough, and whether it will fit into the real world situation. Mixed reality is basically a combination of these two, and whether both the digital objects can interact, or a digital object can interact with the real world, or a real world can interact with the digital product. So you can really do a lot of combination of these, and then get a feel about what is really going to happen digitally when you are coming up with a product or a offering. So this has helped basically to reduce a lot of development cycle times, investments. Like you don't have to invest into the tools to make a real interior of a vehicle. You don't have to make the plastic parts. You don't have to do any fabrication or anything. But digitally, you are able to really understand and identify some of the areas where you need to improve, or you need to make some changes. And it is still a digital review. It's a digital activity which is happening, and it can really help to improve the product and get a better design. Next slide, please. Yeah, I think this is the last one on my list of new technologies. Now, blockchain technology is something which is available, which is being used in a very small pocket. Basically, it's a digital ledger which is used to record the transactions, but it is highly secured because of the encrypted and decentralized nature. And there has been a lot of discussion happening on blockchain. It was really overhyped, perhaps still to be matured, but people are looking at it, and some of the companies have already started investing into that, like FedEx and IBM and Mastercard, and they really want to see whether this technology can help. This technology can, improve their businesses and improve their processes. We also have heard that Facebook is really thinking to launch their own currency called Libra. You already probably have heard about the Bitcoin. That is one currency which has been widely used. So I think that was my last slide, and with that, I would probably open up for question and answers. If anybody has any questions, we can take them now. Another 1 or 2 minutes. If not, then we can always channel it through Professor Sudeep Upadhyay or Dr. Vishwajit Poddar, and we can answer that. So with that note, I come to my small presentation on what is happening in the industrial sector on new innovations and what are the technology trends which are likely to come and we are likely to be part of it in coming future. Thank you very much.
Prakash, wonderful, wonderful presentation.
Thank you.
Very, very nice to listen to your voice and to see you virtually and talking so nicely about innovation. We are really blessed. I would like to request you to please guide our students in a few minutes. What kind of preparations or what kind of mindset these undergraduate students should have while selecting, choosing their projects, maybe at third year, final year, so that this innovation or innovative mindset is nurtured and they can come up with their own unit as such. They can be entrepreneurs in futures with innovative ideas. Briefly, please. Thank you.
Yeah, so I think for the students, first of all, I would say that keep a very open mind, and you be connected with the world you are living in. A lot of things are happening around you. A lot of things are happening around us, and we see every day there are new things coming up, new products coming up, new technologies being introduced, and be open to look at them, be open to understand what exactly is that is something new and how this is helping us. And also don't try to follow the traditional ways. Doesn't matter if you fail in one or two, doesn't matter, but you always learn. Try to uh, explore new things, dare to do mistakes, go out and try different things. Probably you might fail once or twice, but that will really give you uh, confidence what you should not be doing and what you should be doing otherwise. And this is how you really innovate. As I said, Apple, when they launched their first product, iMac, sorry, not iMac, a Macintosh PC in 1977, they miserably failed. There was nobody who was ready to buy those um, PCs. And then they realized that they have to do something different. They have to do something unique. And then after 5 6 years, they came up with another product, and in between they were almost bankrupt, but I think they didn't give up, and every time they tried something new, every time they came up with new ideas, and today we see it's one of the most innovative company in the world. And they started like in any other company in a garage. I mean, there was no big investment at the day one. It was just a small 2 3 uh, wise people. They just came together and then they said, let us do something, and that's how they started. They didn't know where they would land up, but there was an idea, there was something in their mind that they wanted to bring into the physical sense, and then put their energy, put their efforts. They didn't give up, and then that is how we see a very successful company. So in your projects, I think in your final year projects, we are actually, as a part of Matix, we are working with some of the students in Engineering College Pune, and I have given a couple of projects to them. Probably, if I come across any these kind of issues and problems which need a solution, probably I will reach out to you, Vishwajit, and we can work on that, on giving some innovative projects to the students. But my request is, don't take a project like which is available already in the marketplace, and you just do it and submit your uh, report, and then you get the marks. I think you will get the marks, but you will not get the satisfaction of doing something new. So it's always take some challenging project which is not there, or something which is already there, but it could be done in a different way. It could be done in a better way, and that will help the end users. It will help the uh, anybody who is going to use it. So try to look out of the box, try to find some different solutions, better solutions, and take up something which will satisfy your own self, and also challenge your technical abilities, challenge your knowledge, and try to do something different, something better, and something innovative. I would rather say this would help you a lot in the future.
Thank you, Prakash. Thank you very
Thank you.
much.
Yeah. So, any questions or anything anybody want to ask? Otherwise, thank you very much, and I will request Professor Gadwal to take it over now. Thank
So
you.
now, yeah, I request Poddar sir to start with session 1.
Thank you. So, good afternoon, friends. Today I'm going to present to you part of some research work that I did during my doctoral studies. And the topic of my presentation is some studies on effect of particle source locations on ventilation effectiveness in displacement ventilated room. As you know, I'm Dr. V.V. Poddar, Vice Principal and Professor in Mechanical Engineering Department at AGPIT Institute of Technology, Solapur. Just to give you the outline of my presentation, initially I'll be talking to you about the relevance of the topic, the research methods which I have used for preparing this paper or carrying out this research, some experimental and numerical simulations I had done on variety of ventilation configurations. I'll discuss experimentation details briefly. I'll discuss about CFD simulation details briefly. Then I'll discuss the results, those I obtained, and then I'll provide the conclusions, and then my findings I'll try to correlate with the real life problem areas. So, friends, HVAC is the field of research we are talking about, heating, ventilating, and air conditioning system. In Western countries, heating is provided much importance because of the lower temperatures prevailing in those areas. But ventilating in India or throughout the world, ventilation systems are given due importance. And when I talk about HVAC and ventilation part of it, it is mechanical ventilation. We are not talking about natural ventilation as such. So heating, ventilating, and air conditioning research related topic I'm going to discuss. And in that, when we have an enclosed space, what kind of design parameters we should discuss and how to come out with the effective ventilation, mechanical ventilation system. This is briefly the relevance of the topic of research. And as you know, as you can see on the slide, poor indoor air quality. Nowadays, it has become more relevant and predominant, friends. Poor indoor air quality, IAQ, affects human health and human productivity. And though we are not aware, indoor air pollution poses a greater risk than outdoor air pollution. We never realize these things because many a times we don't know that people spend 80 to 90% of their time indoors. Now, this has got reference to United States Environmental Protection Agency and some of the researchers. See, 80 to 90% of time indoors. What do you mean by indoors? See, I am sitting in my cabin. This is also indoors. You are sitting in your room. That is also indoors. So, on an average, we spend 80 to 90% of time indoors. Whether you're in a sports complex, whether you're in a theater, whether you are in a vehicle, you are in a bus, you are in a train, we are into this indoor environment. And that's why that indoor environment poses higher risk than the outdoor pollution. That's what this says. Now, indoor air pollution in India, see, one of the top 10 death factors. So, indoor air pollution can be so life-threatening that it is one of the top 10 death factors or disease risk factors. See, most of the infections, most of the death rates, most of the illnesses are related to polluted air within the indoor environment. That this is what World Health Organization says. Now, out of the pollutants, like we have volatile organic compounds, we have CO, CO2s, various gaseous contaminants, the particulate contaminants pose a greater risk. And in the arid and dry areas we have all over India, we have much of the particle contaminations, and these particle contaminants indoors can lead to major health hazards causing various respiratory diseases like asthma, cardiovascular diseases, lung cancer, etc. So this is also WHO says. Now, as per US Environmental Protection Agency, Occupational Safety and Health Association of America, then ISHRI, National Environmental Engineering Research Institute, and Central Pollution Control Board, CPCB, strongly correlate bad indoor environment having prohibitively higher particulate contaminants to improper ventilation system design. And they recommend detailed research in this area of particulate contaminant pollution. This is what is the relevance, and that's why I carried out some research related to particle contaminants. And this paper is related to one such studies related to particle contaminants indoors. Now, when I'm talking about particular contaminants indoors, a lot of study has been done for the past 3 to 4 decades throughout the world. Much of the work is done in Scandinavian countries, like Nordic countries we call, Norway, Sweden, North European countries. Much of the research has been done, and they have come up with many wonderful solutions for reducing these particulate contaminants. But unfortunately, in Asian subcontinent, in Asian countries, the research is limited. And some studies have been carried out in Singapore and Hong Kong related to particulate contaminants. Now, as you can see in the slide, some researchers have carried out some studies related to displacement ventilation, mixing ventilation, underfloor air distribution ventilation, and they have come out with their performance configurations. Some have carried out experimentations also. But if you just try to find out the gist of all these research work, one gap that I could find out during my own research presentations is that many of the studies are related to Scandinavian countries, and many of the studies are related to comfort air conditioning area as such. And some studies are there related to gaseous contaminants. Very few studies I could find out related to indoor particulate contaminant studies, and that too with experimentation. Most of the studies I found out were CFD simulation based, and most of the data that I could find out was adopted data. What is this adopted data? Somebody somewhere sometime has done some experimentation, and that is taken as a basis, and based on that experimental data, the CFD simulations are run, and the results and conclusions are found out. What I did during my research was, because there is a dearth of experimentation work, I decided to carry out rigorous experimentation in controlled environments and develop this experimentation data related to displacement ventilation, mixing ventilation, underfloor air distribution systems. And this data would be of much help to the future researchers who carry out CFD studies later. So this is what is the literature study I have carried out, and in this particular paper, I am going to present the effect of contaminant particle source locations on ventilation effectiveness in an enclosed room. As I told you, the studies are restricted to enclosed room. What I did for that, I developed one enclosed experimentation room. And as I said earlier, there are many factors which decide the particulate concentrations within these enclosed spaces. The factors like what is the, as I'm talking about mechanical ventilation, what are the air change rates, what kind of air velocities we are maintaining. That also has effect on the particle removal effectiveness. The location of the air terminal devices, the supply duct and the exhaust duct, where they are located, that also has impact on the ventilation effectiveness. The location of contaminants also, the polluting contaminant, the particle contaminants, where they are located, whether they are in the supply air itself or they are within the room, like people are roaming around in the room, or there are some equipments and gadgets within the room, whether they are generating the particles. Typically in an office environment, when I got a printer, maybe a laser printer, is dot printer is there, or there are many devices which are emitting some particles. So in such a case, I have the particle sources within the room. So what I'm talking about, I'm going to study, or I'm going to present to you the results that I obtained related to when the particle sources are one in the supply air itself, when the particles are there, what kind of distribution of particles will be there within this room, and then when the particle source is in the room, how the concentrations of particulate concentrations will vary and how those are distributed within the room. And then ultimately, how I can reduce those particulate concentrations in the occupied zones or where the people are sitting, that I am going to present. So this is how is my present work. Let us first understand what is the occupied zone and a breathing zone in an enclosed room. Now, as per American Society for Heating, Refrigerating and Air Conditioning Engineering, ASHRAE standard 62.1 of 2010. If we have, hope you are able to see the screen. If we have got a room of size, let us say 4 meter by 4 meter by 3 meters, so to say. Now, what is the occupied zone? If you just leave apart 0.6 meters of space from all the sides, maybe east side, west side, north side, south side, top side, bottom side. If you just leave aside 2 feet of space, whatever is the area that is visible is called as the occupied zone. So leave some space from the walls, 2 feet of space from the walls. Whatever is the volume of area, that volume of the content that I have, volume of the room that I have, that is called as the occupied zone. And the breathing zone is maybe from 1.5 meters from the flooring up to 1.5 meters, means around 3.5 feet to 4.5 feet of height within the room. Normally when you're sitting or if you're standing, that is where our head would be, our nose would be, and that would be the area where I'll be breathing fresh air. So that is called as the breathing plane or breathing zone. So that is around 1.1 meters or 1.5 meters to 2.5 meters or 1.5 to 2 meters. That volume of the space is called as the breathing zone. So we are going to find out. Let us see the nomenclatures now. Now this above the breathing plane, the zone is called as the upper zone in a room. Below the breathing zone, I have got a lower zone. So I have got upper zone, lower zone, I have got occupied zone, as you can see in the gray area, and I have got the breathing zone. Breathing zone, the area between 1 meter to maybe 2 meters, maybe 2.5 feet to maybe 3.5 feet, or that area we can define. So that is these two zones. So we are going to study, as I said, we'll be populating the space with the particles during our experimentation, and we'll try to find out what will be the particulate concentrations in these areas, in occupied zones, breathing zones, lower zones, and upper zones. So the objectives to evaluate contaminant concentrations in various zones: upper zone, lower zone, occupied zone, and breathing zone of enclosed room for various contaminant source locations. 2 source locations I'll be presenting today. As I said, I'll be having the air supply duct. Maybe like an air conditioner, I have the air delivery zone, air delivery duct. if the particles are entering from that duct. So that is one location, particle source location. Or second location would be when the particle source is within the room. Maybe the person is emitting, the particulates are there on the human being itself, on his clothes, on his hair, or there are certain gadgets like printers are there, Xerox machine is there, they're also emitting the particles. So these are the two cases I'll be presenting today, when the particle source location is in the supply air and when the particle source location is within the room, both experimentally and numerically. To compute from this concentration data, we'll be able to compute what will be the contaminant removal effectiveness in the occupied and breathing zones of the room. And then finally, to recommend appropriate ventilation system design and operating parameters. So these are the objectives, the methodologies. As I said, I'm going to present some experimental studies and some CFD simulation studies as well. So what are the experimental studies? This is what is the experimental setup. Those who are from AGPIT will be able to identify. This is a physics laboratory wherein we have a dark room, and the dark room I converted into my experimental test room. So this is the air conditioning test rig through which I generated the particles, and I supplied the air through in the controlled temperature with controlled humidity, and I maintained the data related to humidity, temperature, airflow rate, and particle concentrations. And this air is supplied inside this room. This is the dark room. This is the dark room wherein I supplied that air, and this is the traversing unit which can be moved within this room. This is the isokinetic probe which can just suck in that air with the particulate contaminants. And I can adjust this bracket in such a way that at various heights I'll be able to measure the concentrations of the particulates, particulate contaminants within this room. So the schematic sketch, as you can see, this is the sectional view of the same room. I'm talking about displacement ventilation. Briefly, I'll tell you about displacement ventilation. The supply air is provided from near the flooring, and the exhaust duct is provided near the ceiling. So this is called as displacement ventilation system. Like that, I have got mixing ventilation system. I have got underfloor air distribution systems as such. More about it later, maybe in the next research paper. In this paper, I'll be discussing about displacement ventilation. So the air is supplied from the flooring, near the flooring, and then it is exhausted near the ceiling. And as the air is displaced, it is called as the displacement ventilation. And as you have seen in the earlier experimental test, setup sketch, this is how the air is supplied. Now, this is my air conditioning test rig. This is my air conditioning test rig, wherein I can supply the filtered air, conditioned air into this room, and I have a particulate generator. Controlled particle generation I was able to do by using this unit, and I can control the concentrations of various sizes of particles. I used variety of sizes. I used 0.5 micron meter size of particles. I used 2.5 micron meter particles sizes, the particles of these sizes. I used 10 micron meter particles. So I was able to control the particulate contaminants those are supplied inside the room. Right. This is one way, one condition when the particles are to be supplied inside the room through the supply air, and the same particle generator was able to supply the particles within this room. These two cases, as I told you earlier, two cases when the particulate supply is in the supply air, and secondly, when the particulate supply is within the room, right? So these were the measurement location. This is the supply inlet, and this is the outlet. As you have seen the traversing unit, I had just calibrated or graduated this room into 9 locations. I was able to take this traversing unit at these 9 locations. As you can see, P1 is pole 1, pole 2, pole 3, likewise up to pole 9. And I was able to adjust that particulate capturing gun at different locations, 6 different locations: 0.5 meter height, 1 meter height, 1.5 meter height, 2 meter height, 2.5 meter height. and 3 meter height. So in all, I was able to take 54 readings for one setup. Like this, I had 60 different setups, and I have found out the experimentation data of airflow, temperature distributions, and particulate concentrations. These are the various instruments I used. I used hot fire anemometer, I used the thermo anemometer, I used the humidity meter, I used digital temperature indicator, I used fog machines for generating fog, I used air particle counter of Beckman-Coulter, I used particle generator, TSI make, and I used precision weighing machine for measuring the weights of the particles I was using. The experimentation procedure, friends, briefly I'll discuss. The experimental test room was suitably evacuated by reorienting the air supply unit so that the contaminant particles in the room will be removed properly. So initially, the experimental test room that we have seen just now, it was evacuated by using the same air conditioning test setup so that all the particle contaminants are removed from the room, and so that thereafter I can just put in the particles of known concentrations inside the room. The ventilation system was allowed to operate for 15 minutes before initiating controlled contaminant particle supply in the room. This was essential to obtain stabilized airflow patterns inside the experimental test room. The airflow was so adjusted that some positive pressure is constantly maintained inside the experimental test room. This was required to avoid effects of infiltration. Now, what is this infiltration? If the door is opened, some persons are coming or the outside air is coming. So that outside air is prohibited. So the outside contaminants are not allowed inside the room. So that the room becomes contaminant free. Okay. Then the airflow, the air supply velocity, air supply air temperature, room air relative humidity, and wall temperatures were recorded. The air velocity temperature measurements at 54 measurement locations were carried out, and the data was recorded. Now, the controlled contaminant particle supply was started as per requirement by suitably adjusting the flow control valves. Then, the contaminant particle concentrations at supply inlet, exhaust outlet, and 54 measurement locations in the experimental test room were recorded. Now, this procedure was repeated for each setup. And the secondly, CFD simulation studies. As you know, computational fluid dynamics is used for carrying out the numerical simulation studies. I have used Gambit 2.3.16 for geometry creation and meshing, and Fluent 6.3.29. Though this is the older version, now ANSYS Fluent, very latest versions are available. Maybe ANSYS Fluent 12 or 14 is available nowadays. So then I had used Fluent 6.3.29 for carrying out numerical simulations. All numerical simulation studies were based on geometrical details of experimental test rooms. Grid independence check and validation of the model were carried out first. In the numerical study, the Reynolds average Navier-Stokes equations, that is RANS, with renormalization group RNG K epsilon turbulence model were used to predict incompressible turbulent airflow, and thermal energy equations were used for predicting temperature distribution in the model test room. And for predicting the particulate contaminants, drift flux model was used to predict particulate contaminant particle concentration distribution in the model test room. The CFD program Fluent solves the governing equations in the form of discretized algebraic equations. The discretization scheme used for all the variables was second order upwind. Simple algorithm. If you are carrying out turbulence studies, you will come to know this implicit pressure link equations simple algorithm was used for pressure velocity coupling. Momentum discretization was done using quick algorithm. Convergence was considered achieved for the residual value of the order of 1 into 10 to the power minus 5, or when the residual error was reduced to 1 into 10 to the power minus 5. Then we stopped our simulations. This simulation setup details: the chamber volume I used was 56.32 meter cube. Ventilation type is displacement ventilation. Number of cells used is 1.6 million friends. So that is 16 lakh cells. Cell geometry was tetrahedral. Cell volume minimum was 2.3 into 10 to the power minus 5 meter cube to 7.04 into 10 to the power minus 5 meter cube was the maximum cell volume. Air change rate for the simulation, this simulation study, was 3.6 air changes per hour. which corresponds to around 1 meter per second of air velocity. Turbulent intensity used was 10%, supply air temperature was 25.2 degrees Celsius at the time of the experimentation and simulation studies. So these were the two parts of my studies. So first was the experimentation studies, second was the simulation studies. Both the studies or the results of the studies were in very good agreement, and then I am presenting the results from these studies. So initially the concentration distribution, just as an example, I am showing you when the particle source location is in the air supply. If you just see x-axis we have normalized concentration, and on y-axis we have the flooring. And if you go up to the concentrations, initially the concentrations near the flooring is good. This we are talking about displacement ventilation, and thereafter it is particle concentrations vary at various heights, and it is presented at 3 locations. Excuse me. Hello. presentation बरं ठीक आहे आता प्रेझेंटेशन त्यानंतर करूया. So we have, sorry for the interruption. So we have pole 4, pole 5 and pole 6 as the sample readings I have shown. And if we go further into our results, quickly we'll go through the results. This is the concentration of the particulate contaminants. We are talking about 10 micron meter particulate contaminant concentrations within the room. This is the lower zone. I have shown you initially the lower zone contaminant concentrations. As you can see, when the contaminants are supplied through the supply air, and when the contaminants are supplied through the room. So these are the comparative studies of the concentration. Subtle variations are there as far as lower zone particulate concentrations are there. If you go to upper zone, you can see sizable difference. When the supply air has got contaminants, the average concentrations in the upper zones were higher than when the particle source was within the room. This is one more result. And then in the occupied zone, when the contaminants are supplied through the supply air, the average concentrations in the occupied zone were higher as compared to when the contaminant source is within the room. So these are the findings. In the breathing zone, surprisingly, when the particle source is within the room, the concentrations in the breathing zones were found to be higher. And these two are, one is the experimental study and the second is the simulation study results. And this bar is called as the uncertainty bar. When you always carry out experimentations, there are certain uncertainties, experimental uncertainties. So my simulation result should fall within this, the error bars. Okay, so those are very much within the error bars. So as you can see, the breathing zone concentration of particle contaminants was higher when the particle source is within the room as compared to when the particle source is in the supply air. This is the particle removal effectiveness of this displacement ventilation system. This is called as epsilon suffix OZ. Epsilon OZ, that is efficiency of my ventilation system. So the efficiency of this displacement ventilation system related to occupied zone effectiveness. This displacement ventilation system showed higher efficiency or higher effectiveness when the particle contaminant sources are within the room as compared to when the particle sources are in the supply air. And in the breathing zone, the results were reversed. The breathing zone ventilation efficiency or ventilation effectiveness system when the particle sources are there in the supply air. So we need to have a strike a balance in selection of appropriate ventilation system depending on your requirement. If you want lesser concentrations of particles within the breathing zone, you can select which type breathing zone particle removal efficiency. Okay, so the conclusions The average contaminant concentration in occupied zone is higher for the contaminant source location in the supply air as compared to contaminant source location in the room. This I already discussed. The average contaminant concentration in the breathing zone is higher for the contaminant source location in the room as compared to contaminant source location in the supply air. The average contaminant concentration in lower zone is marginally lower for the contaminant source location in the room as compared to the contaminant source location in the supply air. The average contaminant concentration in upper zone is higher for the contaminant source location in the room as compared to contaminant source location in the supply air. The contaminant removal effectiveness in occupied zone is higher if the contaminant source location is in the room as against the source location in the supply air. The contaminant removal effectiveness in breathing zone is higher if the contaminant source location is in the supply air as compared to contaminant source location in the room. So what are the findings? What are the recommendations? For 10 micron meter contaminant particles at lower air changes per hour, the displacement ventilation system provides highest contaminant removal effectiveness in the breathing zone. So if this is your requirement, going for displacement ventilation system if the contaminant source is in the supply air. So these are the major findings. And let me share with you, my friends, this study was carried out in the for the operation theater studies, and these Beckman Coulter systems who provided me support with instrumentation, they adopted many of my results for their practical implementations of design of a clean room for hospital ventilation systems. So thank you all. Hope I've gone a bit faster. Hope you've understood few of the things. I'm ready to take some questions if you have. Otherwise, I'm done. Thank you very much for your patient listening and time. Thank you very much.
Okay, hello to everyone. My name is Mullah Javed, working as lecturer in AGPIT Polytechnic Institute in Mechanical Department, and my topic of presentation is cost analysis of Motogene hybrid scooter. Okay. So before going to discuss about the concept or the anything, one thing that I want to make clear is that, so this is my students project topic. So in this project, what we have done, we have converted conventional moped, that is scooty pep moped, to hybrid vehicle, or hybrid by using hybrid system. We converted it from conventional to hybrid. And in this, what we have done, we use two systems. One is electric system and second one is engine system. Okay, so these are the names of the students. Next slide. Okay, basically discussing the abstract in detail, one thing that I want to make clear is that, so in the abstract it is mentioned that what we have done, we converted our conventional moped, or we converted our conventional moped to electric one. So for the same, what we have done, at front of the engine, at front of vehicle, we use electric motor which is inbuilt in the front wheel, and rear wheel is connected with the engine by using suitable drive. And what we have done, so after successful implementation of this project, we operate this moped on both drives, that is electric drive as well as on engine drive. And finally, what we have done, we compare the average that we get from both systems, that is from electric as well as from engine drive, and finally comparison of fuel cost is done. And at the final, we can see that, so operating scooter on electric mode is economical good. So these are the things that we mention in the abstract. Next. So before going to discuss about the actual product, so let us discuss what we mean by hybrid vehicle. Hybrid vehicle is nothing but it is the vehicle in which more than one power source is present. Once again I repeat, hybrid vehicle is the vehicle in which more than one power source is present, such as engine along with electric motor. So during running of vehicle, both systems may be operative. So because of such systems, it is possible to increase fuel efficiency, and that also decreases emission level of vehicle. So I can say that the examples of hybrid vehicles may be Toyota Pyrus and Honda Insight. These are the two manufacturers, those who manufacture hybrid vehicles. Next is types of hybrid vehicles. So basically hybrid vehicle is of two types. One is series hybrid and second one is parallel hybrid. So in the slide, for both, that is for series hybrid as well as for parallel hybrid, two arrangements are there. And in series hybrid, here we can see that fuel tank is there, gasoline engine is there, generator is there, battery pack is there, electric motor is there, transmission system is there, and wheels are there. So basically here, if we observe the arrangement, if we go through the arrangement, here gasoline engine is in series with generator. Generator is nothing but motor that generates the power, and simultaneously it also generates electricity. That electricity can be used for charging the batteries. Okay, and if we think about parallel hybrid, basically parallel hybrid, or in parallel hybrid, electric motor is present parallelly to gasoline engine. Means both drives are parallel to each other, and their drive is taken, and that drive is given to transmission system, and from transmission system it is given to wheels. So this is the basic arrangement of series hybrid and parallel hybrid. Okay, next slide. Here this slide is for components of hybrid vehicle. So basically hybrid vehicle consists of conventional IC engine, next is motor / generator, then transmission system is there. Basically transmission system consists of clutch, gearbox, and after that various electrical circuits are there. These electrical circuits include energy storage, hardware, software, control, and devices like MOSFET, IGPT, topologies, DC-DC, inverter, multi-level, etc. So these are the components, and by using these components we can build any hybrid vehicle system. Next slide. So for implementing this project, we have adopted the following methodology. This methodology includes in this project for our use, we have selected TVS Scooty Pep Plus engine. Sorry, TVS Scooty Pep moped. So at front of the moped, we have fitted electric drive wheel, and for the same necessary wiring and other arrangements are done. Next, after completing all the fittings, or means after implementing all this project, inspection is done, testing is done. So after completing the test, we note down the average we get by using electric mode as well as by using engine mode. So based on the average and the necessary fuel cost, the comparison of electric drive and engine drive that we have done. So next slide is, this is the flow chart. This is the flow chart. By using this, generally the system is implemented in the vehicle by using this process. It includes 4 steps that we mentioned earlier, so that we can see. So from this flow chart, so this slide is for cost of operating moped using various drives. So it is simple to understand. Here what we have done, at the start we operated this moped on engine. So here we consider the petrol cost is 78.5 rupees per liter. So monthly consumption is of 15 liter, and average after using 1 liter of petrol we get 22 kilometer, and that also in the speed range of 30 to 40 kilometer per hour. So secondly, what we have done, we operate the same moped on electric drive. So in that, for complete charging of batteries, generally it has electric consumption of 3 nits. It has electric consumption of 3 nits. So after burning 3 nits, after using 3 nits, we can charge our batteries completely, and cost for charging 3 nits is 10.5 rupees, and after charging full batteries we get average of 8 kilometer. Okay, and let us assume that if we operate our moped for 25 days in a 1 month, so that charging cost will be around 262.5 rupees. So definitely, if I want to calculate the effective cost, then we can say that saving of cost is equal to petrol cost minus electric cost. So that cost will be 1177.5 minus 262.5, that will be rupees 915. Means, so by if we operate our vehicle by using electric drive, we can save rupees 915. It is the amount of cost that we can save if we operate our vehicle using electric drive. So it is the big amount that we can save if we operate our moped on electric drive. So this is, here we can see the comparison, and we can say that operating the moped using electric drive, it is always economical one than petrol cost, because today if we see, day by day petrol prices are going to hike, going to increase. It is getting increased. So nowadays it will be better if we use our vehicle on electric drive, and if we operate the same moped on electric drive for the same running, we can say that we can save a big amount. So that amount is 915 rupees. So discussion of result is nothing but, so in the result we can say that from the test result we can see that if we operate the moped using electric drive, then there is considerable saving in cost. The cost of operating moped using electric drive, it is 22.25% of total petrol cost. For the same average, we can also say that the fuel cost gets decreased by 915, that is 77.70%. Okay, by this much amount we can save the money. Next, this slide is for conclusion. So if we want to discuss the conclusion can be discussed in this way. By considering both drives, that is electric and engine, whenever we operate moped using electric drive, fuel cost decreases drastically, and that also environment friendly, because of no pollution, and second conclusion will be because of both drives it is possible to operate moped either in electric or in engine drive in case of failure of any one system. And third conclusion will be by using electric drive maintenance cost can be less, definitely moving parts will be less, so we can say that our maintenance cost also gets decreased. And fourth conclusion will be the hybrid vehicle will be useful in remote areas, as in such areas where fuel is not available easily. So these are the four conclusions that we can take from our paper or project. Okay, next slide. Okay, here my presentation gets over. Thank
Okay, thank you, sir. Now we'll go for vote of thanks. So I request Professor Chokole sir to deliver vote of thanks.
So first of all, I am very much thankful to all the participants, faculty members and the students for attending this particular conference with complete sincerity. And I am very much thankful to the management of our college, AG Institute of Technology, for providing the platform and the resources to organize this particular NITET 2020 conference. Later, I most thank our principal, Dr. S.A. Patil sir, Vice Principal and the convener of the conference, Dr. V.V. Poddar sir, co-convener and the HOD of the Mechanical Department, Dr. S.B. Gadwal sir, for continuous support and guidance for successful conduction of this particular conference. And last but not least, I most thank our keynote speaker, Professor P.K. Kulkarni sir, for your valuable time and a very nice and the knowledgeable presentation. Definitely, it will help us in the future for the research works. Then I most thank all the participants, all the faculty members, all the students, and all the persons who are directly or indirectly involving for the success for this particular conference. Now I request all the participants to please switch on your video so that we can take a group photo. I request all the participants to please switch on your video so that we can take the group photo. The recording of this particular sessions that we have conducted today, plus the presentations of the remaining participants will be available on the YouTube channel of AGPIT, on the YouTube channel of our institute. At the end, I must thank all of you, and with the help of all the dignitaries, I declare that the conference is over. Thank you, Vanessa.
Thank you, Prakash. We'll talk in the evening. Thank you.
Yeah. Thank you very much. I think it was a good participation, and I really could get a feel about the activities happening there and about the institute. So thank you very much, and we'll be in touch, Vishwajit, definitely.
Yeah, sure.
Yeah,
Sure.
thank you.